Hello again, everybody. This is Tom from Every Step Calculus, everystepphysics.com. I've been working on the physics side of my program, so I haven't gotten into calculus here, but I want to do a video today of this. I'm still into partial fraction decomposition. I've found about 8 or 10 different ways of factoring the denominator of things. Now this denominator here, good luck in factoring that yourself. You know, you'd have to use the calculator to do it, which has the factor button on it. You know, for instance, notice up here is if we press F2 here we have factor. So if you press number 2 and got it going on the calculator and then entered this denominator here, you would come up with this factor. And factoring is the key to partial fraction. If you can't factor the denominator, you can't do the problem. You can't find the integral with partial fractions. So keep that in mind. Anyways, we're going to use index 8 here. I'm going to get back to the home screen by pressing the home button here. Index 8 to get to my main menu. Of course, this instructions come with the programs that you buy from my Every Step Calculus site, and of course all the instructions on how to put this in here and how to get going with the programs is fully instructed in my instructions. So index 8 to get to my main menu, press enter. I already have it here now at, you can see partial fractions. It's 170 items in the index here. Whatever you would see in the test, you would go here to the index and it would come up and do the program for you or do the problem for you. And notice that it's so much better than the computer, because you can't take the computer into class with you, but this one, TI-89, you can take it and do your homework at the lunchroom, or take it into the test if you want to do that. And so it's pretty neat. And of course everything in here, you can throw away your calculus book, you know, but don't ever throw away this titanium calculator once you load my programs in it, because in the future you may have to upgrade to some sort of calculus in business or something like that, and all that's in here ready to go for you. So anyway, you're going to press enter for partial fractions. We'll get to the partial fraction program, and we enter the integral here. Now I've already entered the integral in here so that it's quick, otherwise it might mess up too. The simulator sometimes messes up when you get all the way down to the end of the program and it'll start recurring or start recopying stuff. So I've already put the integral in here, but when you buy my programs and put them in the calculator, you're going to press second alpha, and then you put X, you know, and the capstan here for squares, you know, and then 2 division sign, etc. Make sure you use the parentheses in the denominator. That's important. And the numerator also, if you have more than one term. So anyways, I've already, let's say that we press second alpha and we put all this in here, okay? We press enter, and here it comes up, shows you what you've entered, and then of course you can change it if you want, or you can press OK and go on with the problem. I factor the denominator for you, so if you put this problem in, you wouldn't have to know how to factor the denominator, because I would do that for you here. And then we're going to set up the problem. Notice in mathematics you have to do everything from the left side of an equation as you do on the right side. Well, we're going to multiply times the denominator on both sides and come up with singular linear problem terms here. So on the left, when you do that, you come up with x squared. And then the right side, we set up the partials. A over x minus 6 plus b over x minus 6 squared plus c divided by x plus 7. Now when you set up these partials, this is a tricky part about it, so this is the important part of it, because a lot of tests you might just have set up the partials for it, you know, in your test, and then you have to know what to do. Anytime you see a square here like this, in partial fractions, you divide that. Notice that x minus 6 times x minus 6 was the same thing as x minus 6 squared, right? So then you put a, every time you see a square here, you're going to put a and b in here, right? And the a is going to be x minus 6 and the b is going to be x minus 6 squared. So just remember that. Very important point for partial fractions. And even if you don't have the calculator, you're going to be able to do that. And then you have c would be x plus 7. Okay? So I've done that for you here. Calculator does that. And we're going to multiply these partials by the factor denominator, okay? And we're going to eliminate the denominators on them. So we're going to multiply, here's the denominator, and we're going to multiply the whole problem here by that to eliminate these denominators in the partials. I do each one for you. Notice that you have a over x minus 6. Well, here's the squares separated, and if you take out one of these x minus 6's, you get an x minus 6 x plus 7. So here's what a would be, right? Let's go with the b, x squared in here. Take that away, you got x plus 7, right? C over x plus 7. Why we take x plus 7 away from the denominator term here, and we get x minus 6 squared. So here's a summary of the partials we've just done. And now we got to expand it to do the problem. We got to expand the right side. We're going to take this using the FOIL method, F-O-I-L. Remember that in algebra? And first times the outside times the inside times the last. And here's what you get. And then you multiply it times A. The B term, bx plus 7b. B times x, b times 7, right? Okay. And the c term, here's the square. We got to square that again, expand it, comes up to this, and then we times c, come up with that. And now we're going to combine the terms within what this is what we just found here. Now we're going to combine these because note we have a squared and we have c squared, and we have similar terms like, for instance, ax bx. So we're going to combine those terms. So we get a plus c over x squared, or times x squared, a plus b plus minus 12c over x, or times x, etc. The coefficients of the numerator, here's x squared. You have to finish it out here, x squared plus x plus the constant on the end. Well, we only have x squared here, so there's a constant in front of that, which is just 1, okay? The rest of them are 0x and then 0. So 1x squared is going to equal to a plus c x squared. Well, all the x squareds dump because they're on both sides of the equation, and so you get 1 equals a plus c, and then we just do some minor algebra, and a equals 1 minus c. 0x is equal to 1 times a plus b plus minus 12c, x, you're on the end, you're a little bit off the screen. 0 equals 1 times a plus b plus minus 12c. And then this is exactly how you do it on your paper if you were to do the computations for the finding these a, b, and c values. And after we do the computations, c is going to equal to 49,169 over 169. Then we dump that into here, substitute c into the first equation, 120 over 169. And then we sub c into the b term, 13c plus minus 1. And we're going to get 36 over 13. So that's what a, b, and c equal. Here's the original partial fractions here. And then we're going to substitute a, b, and c, which we done here. 120 over 169, etc. of the partials. So now we got the integrals set up here. And so we're going to do the integration of these, each one of these. First, we're going to integrate first, which is use substitution. And we have u equals x minus 6, etc. dx, write this on your paper. Here's substituting u. And then when we do the integration, anything under the denominator is just one or two terms is log of u. So there's the answer. And we sub in the x minus 6. Here's the answer. That's the first integral. Second integral is use substitution again. Use substitution, x minus 6 is going to equal the u. And then du is equal to 1. Remember the constant, you don't do derivatives of constants. Put that on the other side and have dx. So now we're substituted. And here's the answer here. And then the third one is use substitution too. So we're going to use that. This times u plus 7 is u. But still the derivative of u of x plus 7 is 1 dx. We would write with the u in there. And then we substitute x plus 7. So here's the answer for that. So here's the original integral. And here's the answer for the integral. Like I say, it's not important here to know how to do this problem, because if you're like me, you could care less about doing calculus. It's a useless mathematical concept I found after 30 years of studying it. And notice that the answer is harder than the original problem. And remember that when you find the integral of something, you're finding the area under the curve. If you graph this, you're finding and then of course you made it a definite integral, giving parameters, maximum and minimums of the then you can find out the exact area of the area under the curve using the x-axis for the base of the area. So anyways, go to my site, buy my programs, and enjoy passing calculus, let me tell you. And I'll help you too if you buy them. Of course, I help you. You can call me on the phone. I'll talk to you and help you with calculus. Help you with the programs, whatever you need. My interest is that you pass, like me, that you pass calculus and get out of there, never to touch it again, okay? So have a good one.